GM, and welcome to In the Sheets with Dappa Dan. In the Sheets is a show where I go through Web3 protocols, white papers, and reports, and try to understand from a developer's perspective what's important. In the Sheets, get it? Like paper. What else would this be about? Oh, in this episode we're going to look at Eigen, the Universal Intersubjective Work Token White Paper. Let's get in the sheets, shall we? Just to start, can we all just appreciate how this white paper starts? The significant evolutionary advantage of humans rests in our ability to cooperate in large numbers. I mean, we are talking about the human race here, people, not some fancy crypto concept. Whoever wrote this probably was like, I'm done for the day, boss. It ain't getting any better than this. This paper famously introduced us to the concept of intersubjective work tokens. Intersubjective sounds like a fancy word you would use to impress your mom that you're doing something really complicated.
What are you doing in there?
Yeah, just working on some intersubjective work tokens here, Ma.
Oh, that's good. I love you.
Yeah, I love you too, Ma. But what exactly is an intersubjective token, you ask? You are asking that, right? Introducing the intersubjective work token. The paper actually does a good job of defining this. First, at the starting point, let's start with the work part. This is a token that's not just for spending for cute little treats for yourself, but for staking. Staking has two different purposes: permission to do the work and punishment if you don't do the work. You can sort of think of this as like your employee ID card. The card gets you into the building, but if you do a bad job, you're probably gonna get fired. Now to the fancy word of intersubjective. Most of the work tokens, let's say when staking ETH, is applied to one specific task, validating the network. But what if you could use a token to apply to a whole list of different tasks? And what if you can just take ETH and make it a universal work token? This is exactly what Eigenlayer does, and why it's important to developers to understand, because it supports the main star of Eigenlayer, which is, no, not him, them, yes, actively validated services, or AVSs. You've heard about AVSs, right? Okay, I got you. AVSs are networks or services that perform some sort of verifiable or validated digital task or job. To really understand this, let's take an example of a line layer. A line layer allows developers to send their ZK proofs and get back verifications of them. Then a line layer aggregates those proofs over time and eventually posts them over to the Ethereum blockchain. So as the developer, if I'm looking for fast and cheap verification for my application or my game, there's only one place I'm looking: a line layer. The possibilities of what an AVS can do are pretty endless, but there's one restraint, and that is the return of our good old friend, intersubjective. Because the task must be intersubjectively verifiable, which means that two reasonable people, if you can find them, should be able to tell if the job or service was done correctly or not. That is why it's great to have a work token that can be used for staking over many different tasks and not just one. Hey, don't fall asleep yet. This token can do so much more. This token also forks. You see, sometimes things go wrong, and there's not always cake to help it. In the world of Eigen, these are called intersubjective faults. Basically, when the task performed by the AVS is incorrect. The paper gives examples like if a token exchange does not present the right exchange rate, or performing some sort of AI inference task that don't perform correctly, or we expect some sort of data to be available and it's not there. Faults should be observable in real time or after the fact, and the results should be objective. So having an AVS task answering the question of who's the cutest Web3 developer in the world won't cut it. In order for the token to be properly forkable, the paper lays out 4 key characteristics. 1, being universal. Remember, since there's a variety of tasks that an ABS can complete, it needs to cover all of those grounds. In order to do this, there's a separation between how Ethereum would handle faults through forking the entire network and how Eigen handles faults forking the specific work token. The second characteristic is the separation from DeFi applications. In case the token needs to be forked, you would have to also update any protocol that uses the token for DeFi reasons. To get around this, the paper lays out creating 2 tokens. The first one, Eigen, used for non-staking apps like DeFi, and B-Eigen, used for intersubjective staking. So whenever a fork occurs, you have B-Eigen 1 and you fork to B-Eigen 2. The third characteristic is metering the social consensus. Basically, this means Eigen is allowed to sort of sort out its own mess without getting the ETH quorum or consensus involved. The paper calls this overloading. Fourth, compensation to users for their loss due to the faults. I mean, who doesn't love a bit of compensation for faults? Well, this means it takes 2 numbers, the deflation per fork, DPF, which is the amount we plan to throw away or burn after the fork to B-Eigen 2. The second one is commitment per fork, CPF. This is the minimum amount a challenger is willing to stake because they believe there's been a fault. And although I hate sports analogies, you can sort of think of this when in American football, the coach can challenge a call by the referee, and if that decision stays, they lose a timeout. If the call was incorrect, then the call gets reversed. In this case, the challenger loses B-Eigen 1 tokens they put up if there isn't a fault, so we can continue like nothing happened and keep using B-Eigen 1. Or they will redeem the same amount of tokens in B-Eigen 2 if the fork happens because of the fault that was detected correctly.
Woof. That was a lot. And the future of EigenLayer is bright. But that future won't ever happen if we don't get any sleep. So, it's time to go to bed. GN.